Okay, so now that we've done a healthy review of recursive algorithms, I want to go into our recursion questions that we had on the study guide and go over those. And the first one is probably the most difficult. And if you notice, I've slightly modified this from the first one that you've seen. And what I've tried to do is just eliminate variables that we didn't quite need and make the algorithm a little bit less complicated so that you can focus on how it works rather than what variable is going where and that kind of thing. And to start off, the goal of this algorithm, what it's designed to do, is to take an input word, and instead of user input, I'm going to just go ahead and put a standard word in there so we can simplify things and not have to deal with that. The goal is to take your input word and collect all the z's from that word and put them into the variable z's. It's what the algorithm is actually designed to do. And our job in this question is to check and see if it actually does that, or see what the end result is going to be. So we start with our instance variables, and our instance variables are the string word, which carries the original word, and z's, which is actually going to be, and I'll write this down, it's going to be our variable to hold the z's collected. So we're going to collect all the z's from our word, and we're going to collect those and we're going to put them inside of the variable z's. And our loops always have four things, which is a starting point, in this case our integer I, and the amount and frequency of our iteration, and then what we're actually going to do as long as the loop runs. How are we going to operate? What are we going to add to what? What kind of equation are we going to do? So let's start with our starting point. Just like most of our for loops, we have the integer I that we're going to use as our iterator, and we're starting it off at 0. And the way we do that is our recursive method is called collect z's, and it has a single parameter that collects our iterator number. Now that number is going to start at 0. So 0 is actually our starting point. So this is actually the same thing in our for loop as when we write int I equals 0. So we start I off at 0, and we run the loop as long as I is less than the length of word, and we add 1 to I each time the loop runs. Then we take the string that is at the position I. So this is basically like saying, here's a piece of the string that I'm bringing in for word, and let's see what letter's at position I. And we're going to store that into the variable L. If L is equal to a Z, we're going to add L to our variable Z's. If our variable is, if L is not equal to a Z, in other words, otherwise, we're going to return a recursive call to collect z's, and in place of our old integer I, which was 0, we're going to place the new I, which is now 1 higher because we've added 1 to it. So that's going to run again, and that's how we iterate forward with I, as we add 1 in here. So that's our iteration. So this algorithm, this loop, is going to continue to run as long as I is less than the length of word. We're going to proceed with all of this stuff, at the end of which is a recursive call to collect z's that starts the loop all over again. And it just continues to do that until I place a value in here for I that ends up being greater than or equal to the length of the word on the other end. And once I reaches a value that's greater than or equal to the length of the word, we're just going to return the actual string itself, and it's going to get stored in all the z's that are from the original string should be stored inside of the variable z's. So let's start with our word pizzazz, and we'll just go for it. We're going to run collect z's at 0. So 0 goes here. If I is less than word length, we're going to do all this stuff. I is less than word length, it's equal to 0, and word length is 1, 2, 3, 4, 5, 6, 7. I is less than word length because it's 0. So I equals 0. And let's see what z's equals. So we add 1 to I. So I is now equal to 1. And then L is equal to position 1 there. So remember that this is indexed from 0 to 6 because it's a 7 long. So it's going to get indexed from 0 to 6. So position 1 is actually the second position. So the first thing we do is we add I to z's. So that happens before anything else. So we'd never get a chance to add the p to z's. And we're not adding the I to z's in this case because it's not a z. Because that only happens if it's equal to a z. So at position 1, we're at I. But a big problem here is that we skipped the p. So this I is kind of in the wrong place. And then if you can look forward to what happens, we're going to iterate forward until as long as I is less than word length. Let's say, and that at this point is equal to 6. Let's say we continue to iterate until I is equal to 6. So let's say I is equal to 6 going in here. That 6 is definitely less than word length. But what's going to happen is we're going to have I plus plus before we call the substring. So then I is going to be plus 1, which is equal to 7. Now, then we're going to call this the index 7 on word, which does not exist, and that's going to give us an index out of bounds error. So that is why the answer here was E. Now, if we wanted to fix this, it would be pretty easy because we already know what the problem is. And the problem is that we're adding 1 to I before we call the index to set the value of L. If we just reverse this, called the index to the value of L, and put our I plus plus here, we could run that and we wouldn't get an index out of bounds. And that would actually collect our z's the way they're supposed to be collected. And we can check that since we have an instance variable for z's. We can just print out z's. And you can see we get all 4 z's from the word pizzazz into z's. The other thing that we can do here that's pretty cool is instead of going plus plus here, I can say in my return, I can just say return I plus 1 instead of regular I, and I always also get the 4 z's back. So that's how this one works, and that's how you fix it. Your only other job here is to try and see if you can make the rest of these other conditions work. But once you know how it works, I think that'll be pretty easy. So give that a try on your own and let me know if you have any questions.